All right, looking at 10.4, and what we're talking about today is going to be what's called the inverse function. An inverse function. And so what this is basically is we're going to take all of our x and y values in our function, or it could just be a relation. It doesn't have to be a function. Remember, function, the difference there is a function passes the vertical line test, right? One x value gives us one y value. But we're taking all of the ordered pairs and we're switching the x and the y. Okay, we're taking the ordered pairs, we're switching the x and the y. That's what makes it an inverse function or an inverse relation. So let's take a look at what that would actually look like. Actually, let's put a definition down just to have it. Or put it for this core concept you see there. For an inverse relation. Like I said, it doesn't have to be a function. A lot of the stuff we're going to look at are functions, but they use the word relation instead to cover everything. So when a relation contains a comma b, the inverse relation contains b comma a. We're switching the x and the y values. So again, we're switching the x and the y values. So when we see this problem where it just simply says find the inverse of the relation, if they're just going to give us ordered pairs, all we have to do is take each ordered pair and switch the x and the y. So I don't need you to do this, we're just going to look at it. Okay, and you can see it here. They just switch every x and y value and each ordered pair. Okay, and that becomes the inverse relation. Okay. So if they ask you a question like that, pretty easy. Take your x and y, switch them. You're going to see some that are exactly this easy. Okay, exactly like this. They're going to give you a bunch of ordered pairs. You just got to switch. Okay, inverse relations. And they could be ordered pairs. It could be as a table, right, or an x-y chart. Same thing. You're just going to switch your input and your output. Input, output. Remember, just another name for x and y. All right, so we're switching. All right. Good. So now, let's get to the harder part. So the next type of question they're going to ask you, they're going to give you a function. Okay, we're getting into these functions now. They're going to give you the function, and they want you to solve it for x. Okay, so first thing we're going to do is we're going to take that f of x, we're going to replace it with a y. Okay, we know f of x just stands for y, so we're going to replace it with a y. Okay, we're going to do this problem. Let's write this one down, at least that original equation. We got f of x is equal to 2x plus 1. We're going to change that f of x into a y. And then it wants us to solve for x. So it means get x by itself. We've done stuff like this in chapter 1, right? Where we're just rearranging, we're getting x by itself. Okay, so I want you to go ahead and do that. Y is equal to 2x plus 1. I want you to get x by itself. Move everything else to the other side. Okay, we solve for x, we get x by itself. That means we're subtracting 1 from both sides, right? We're getting everything else to the other side. And then we got to divide by 2. We're going to end up with x is equal to y minus 1 over 2. We can leave it just like that. If you wanted to simplify it, then it would be y over 2 minus 1/2. You don't have to. We can leave it just like this. All right, questions on that? Solve for x. Great. Remember how to do that. But then the second part says find the input when the output is -3. Remember, input is x, output is y. So they're telling you to find the x value when y is -3. So that's a lot easier once we have solved for x here. Right? We got that x by itself. So all we have to do is take that -3 and plug it in for y. We'll take that -3, plug it in for y, we're going to get a number out. What number is that going to be? What are we going to get when we plug that -3 in? We're going to get a -2 out. All right, you plug that -3 in. Marker is just about gone. Plug that -3. Can't even see that. Plug that -3 in. That's -3 minus 1 over 2, which gives us -4 over 2, which of course simplifies to a -2. Okay, so that's what we're looking at in this type of question. We're going to get x by itself. We're going to plug in the number for y, and then have that x value. Questions on that? Okay. All right, what's your practice with? Okay, we got 3 of them here. You're going to solve for x first, and then you're going to plug in a 4. Okay, but you're going to solve for x first. You're going to x by itself for each one of these. First 2 we should be okay with. That third one, we're going to give it a shot, and then we'll talk about it. All right, find somebody around you, see if they got the same thing for me. All right, let's take a look at these first two. First one is very straightforward. Just add the 6 over. We get x is equal to y plus 6. We plug in a 4. What do we get? 10. Thank you. For number 4, subtract the 3. We get y minus 3. Now we got 1/2 x is equal to y minus 3. Get rid of that 1/2. Going to multiply by the reciprocal, which is 2. When I'm multiplying by 2, I got to multiply that entire left side by 2 though. That has to go in parentheses there, because we're multiplying the entire side by 2. So then I distribute that 2 into that whole side. That's going to give me 2y minus 6 is equal to x. Okay, common mistake there is to not multiply the entire left side by 2. It's got to be that whole side. Okay, so we got 2y minus 6 is equal to x. When I plug in a 4, what do I get there? 2. Right? Because I plug that in, that's 8. 8 minus 6 gives us 2. So our answer would be 2. And then we take a look at 5. What do we get for 5? Okay, what'd you get for 5? When you plugged it in?
Oh, yeah.
Okay. How about the equation? Who's got an equation for me? Hey, what do you got? Root y equals 2x. Okay. But we got to get the x by itself, right? Levi, what do you got?
I got that's the root of 1/4 y.
Square root of 1/4 y. Okay. Yeah. So like that.
Yeah.
Okay. All right. Good. We can simplify this a little bit, but we're right there. Yeah. So here's what we're gonna do. Right. We got to get x by itself. So I'm going to divide by 4 right away. I'm going to divide by 4. I'm going to get that x squared by itself. And we will see questions like this. Okay. So I'm going to divide by 4 right away. That's going to give me x squared is equal to y over 4. Right. Now that the x squared is by itself, now I can take the square root. So I'm taking the square root here. I'm taking the square root here. That's going to give me the square root of y over 4, but I can simplify that bottom, right? I can simplify the square root of 4 into 2. That's going to give me the square root of y over 2 is equal to x. Okay, the problem though is I took the square root of a number in an equation. What do I have to do anytime I take the square root of a number in an equation? What do we have to do back in chapter 9? Plus minus. Anytime you take the square root of a number, it has to become plus or minus. Every single time you take the square root of a number in an equation, it has to be plus minus. That was not just a quadratic thing back then. Okay, so it's plus or minus square root of y over 2. This is our equation right here. That's that equation that we come up with. So when I go to plug in the 4, plug in a 4 in for y, the square root of 4 is 2. So I got 2 over 2, but I got plus or minus 2 over 2. So my answer is not just 1. My answer is plus or minus 1. Okay, so that's something to be aware of here today, is you are going to end up with those plus minuses. Yeah. Because the first thing they ask you to do is solve it for y, or solve it for x. That's why. Yeah, I mean, if they just wanted, when the output is 4, find the input, then yeah, you could plug a 4 in here and solve it. Yeah. But they asked us to do that first, right? Any other questions on this? Okay. So we're going to take that same general idea, and now we're going to find the actual inverse function. Okay, it's very similar to what we're doing here, but we're going to find what's called the inverse function. So again, this is, you are going to be asked to do stuff like this on the homework. Okay, you're going to be asked to rewrite those ordered pairs and just switch the x and y. You're gonna be asked to solve for x and then plug a number in. And then the last thing that they're gonna ask you to do is they're gonna ask you to find the inverse. Okay? And before we look at a problem, we got 3 steps. Let's write these 3 steps down. I don't like what step 1 says. I'm going to change it. Change f of x into y. That's step 1. Let's have these down in our notes so that we can go back and look at them when we get stuck tonight or before the test later this week. So 3 steps. We're going to change f of x into y. We're just going to rewrite it with a y instead of an f of x. We're going to switch the x and the y. And then we're going to solve it for y. Okay, those are our 3 steps. It ends up being very similar to what we just did. Okay, the difference is we're switching our letters. So for the first one, our first step, make this a y, right? And so when you're writing it down for the first time, you're just going to write it with a y instead of an f of x. And then we're going to switch where the x and the y are. So we're just taking that y, we're going to change it into an x. Take the x, change it into a y. And then step 3, solve it for y. Okay, how would you go ahead and solve that for y? The y by itself. We're just getting y by itself here. Okay, your y by itself, we add the 9 over. X plus 9 is equal to 4y. We divide everything by 4, and we get our new inverse function. Again, the only difference between what we were doing before is now we're switching the x and the y back. That's it. I switch the x and the y and solve it out. We've got our new inverse function. There you go. Now, the thing about the inverse function, if we were to graph the original and graph the inverse, we could graph both of those. Right? We could simplify this into a y equals mx plus b if we wanted to. Right? X over 4, that's 1x, so that would be 1/4 x plus 9/4 if we wanted to. You don't have to, you can leave it like this, that's fine. But if we were to graph both of those, what's going to happen on that graph is they're going to be reflected over this line y is equal to x, over this diagonal line. Okay, they're always going to be reflected over that. So it's going to cross on that line. Okay, and so you're going to have some questions that are going to ask you to just graph both of those lines. Just know when you graph both of those lines, it's going to end up looking something like this, where they're going to cross. That point where they cross needs to be on this y is equal to x. That y is equal to x line, right? That's because that contains 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. that inverse that you are creating, right? Let's say that I plug in, what was that original problem? Y is equal to 4x minus 9. Let's plug in a number. Let's say I plug in a 2. Right? I plug in a 2. It gives me 8 minus 9 gives me -1. So this equation has the point 2, -1. Since I found the equation of the inverse, if I switch those two, that should be a point here. I should be able to plug in that -1. I plug in the -1, that's going to give me 8 over 4 equals 2. So this inverse will have that switched, right? Just like we talked about at the start. The inverse is just the x and y switch from right ordered pairs. So any ordered pair you have here, we switch it, we should have it down here. And we can see that on our graph, right? We've got this point, which is like 2.1 comma 0. So I'm going to have 0 comma 2.1. Those points are just going to switch, right? And that's going to be true every single time. All right, so we are simply switching those variables, solving for y, and then they might ask you to graph it as well. Questions on that? Okay, we gotta look at 2 more here. Here's one. We simply have y is equal to x squared. Y is equal to x squared. Go ahead, switch the x and the y, solve for y. Make sure we get the right thing. Switch the x and the y. We now have x is equal to y squared. We need to get y by itself, not y squared, but y. So I have a squared, so I take the square root of both sides. So y is going to be equal to that square root of x. When I took the square root of something, technically it should be plus or minus the square root of x. Okay? Plus or minus is going to show up every time we take the square root. It's going to be a plus minus. We can't forget about that. Okay. All right, and then it says graph the function. You're just going to be choosing the right one of big ideas. Okay, you're going to choose the right one. We know that we could simply plug in a number and get a number out. And so that's how you're going to choose the right graphs for that. With this right here, that would be that equation. This is what we're actually going to have to find, is that equation. Now we could also go the other way, where we have something like this. This is going to be the last problem that we're going to look at. We got the function, the square root of x plus 2. Y is equal to the square root of x plus 2. So again, we're going to switch where x and y are. We're going to rewrite it as x is equal to the square root of y plus 2. We're switching x and y. And then we got to get y by itself. So go ahead and get y by itself here. Do what you got to do to get y by itself. Okay, so we square both sides. All right, got to get rid of that square root. If x squared is equal to y plus 2, subtract 2, and we get our equation. Y is equal to x squared minus 2. Okay, there's no plus or minus here because we didn't take the square root of anything. So we've got this. So what we know by these last two examples is that something that is quadratic, right? This is quadratic because it's got the x squared. The inverse of a quadratic is a square root function. The inverse of a square root function is a quadratic. They go back and forth. If you remember, you think back to what this graph would look like. This graph's going to look something like this, right? Our square root function was always like that. If you turn your head like that, this is half of a parabola. Square root function was half of a parabola. If I reflect that, I've got a sideways parabola now. Okay? We never drew that part because we can't have the negatives. But if I go to create or graph this, right, the inverse function, and it tells us, well, we have to know because this is just the positives, we're going to have something like this as our inverse. We're only going to be looking at the positive version. So you'll see it today. You'll see in a lot of problems. We saw in the last one that we saw. It said something like when x is greater than or equal to 0. Because we're only going to be dealing with the positives here. Okay, so you're not going to be having that whole entire parabola. We're going to have this. So these two are inverse functions. And remember, those inverse functions are always going to cross on this y is equal to x. And it's just a reflection of that. So again, a quadratic and a square root are inverses of each other. Okay, we didn't really point that out before with that square root, but it is half of a parabola. It's just on the side. Okay. All right. So a little bit different here, what we've been looking at today, doing some manipulation of equations, but I think we'll be all right. Any questions right now, what we're doing? Okay. That's it for 10-4. Okay, that's it for 10-4. We should be good. Let me know if you have questions on it.